Hello, my dear students. To start with, I would like to ask you a question. Have you ever seen an opera singer break a glass with her voice? Seems fascinating, right? But how exactly does she do that? Well, this is because of a phenomenon in physics called resonance. But what exactly is this? Let's clear our concepts about resonance in today's video. To understand the concept of resonance, we will first have to understand what are natural vibrations and forced vibrations. Let's start with natural vibrations. Each and every object has a natural frequency of its own, and this is the frequency in which it vibrates when there is an absence of an external periodic force. For example, let's take a tuning fork and say it has a frequency of 440 Hz. So it means that when struck, this is the specific frequency in which it is going to vibrate when there is an absence of any external force on it. And the vibrations thus produced will be known as natural vibrations. On the other hand, when an object vibrates under the influence of an external periodic force, the vibrations thus produced by the body are known as forced vibrations. For example, first tap on a table with your hand. Then take a vibrating tuning fork and tap it on the table. In the second case, you will hear a different sound. This is because the first sound heard was due to the natural frequency of the table. In the second case, now the table is vibrating due to the tuning fork, and its frequency of vibrations is equal to the frequency of vibrations of the tuning fork, which is different from its natural frequency, and therefore you hear a different sound in the second case. The vibrations thus produced by the table in the second case are known as forced vibrations. Now coming to resonance. Resonance is a special case of forced vibrations. In this, the frequency of forced vibrations becomes exactly equal to the natural frequency of an object. And when this happens, the object starts to vibrate with a greater amplitude. And the phenomenon is thus known as resonance. For example, let's do an experiment. Do an experimental setup as shown below. To start the experiment, strike the tuning fork of frequency 512 Hz. In this case, you will not notice much difference. Now replace the tuning fork of frequency 512 Hz with a tuning fork of frequency 440 Hz. This time you will notice that the ball starts to oscillate. Do you know why this happened? Pause the video and think about it. Since the mouth of both the wooden box are kept close to each other, when struck, the tuning fork A starts to vibrate under the influence of tuning fork B. Tuning fork B is the source of forced vibrations, and the frequency of forced vibrations is exactly equal to the natural frequency of tuning fork A. Therefore, tuning fork A starts to vibrate with a greater amplitude, and thus the ball also starts to oscillate. The example which I gave in the starting of the video, that an opera singer breaks a glass with her voice, is because the natural frequency of the glass is exactly equal to the frequency of the singer's voice, which acts as a source of forced vibration. And thus, due to resonance, the glass starts to vibrate with a greater amplitude and it breaks. I hope now your concepts about resonance are clear. If you liked this video, do subscribe to my channel and write in the comments on which topic should I make a video next. Thank you for watching.